One of the most fun things we do in this hobby, one of the most fun things in amateur radio is assembling the equipment that then becomes your station. And Gordon West, WB6NOA, recommends, particularly for new amateur radio operators, to look at maybe buying a handheld. How do we do that, and what are the considerations? Running over a new radio with a truck is one type of test, but not a good idea at all. Here's another test that we never get to perform on radios. We all know what happens when these radios get wet. Not a good sight. But would an ICOM D-Star radio handle it? 1, 2, 3, 4. Looks like it works underwater. I like to start with the catalogs, and DX Engineering is a fabulous catalog because DX Engineering is the only company I know of that makes an awful lot of their own things. So you see more when you shop with this catalog. And if we're going to look at portable radios, we see right off the bat that there's a list of portable radios here. And of course, everybody compares price. And price is critical for a lot of amateur radio decisions. But let's look at what else sticks right out. All of a sudden, when we look at these, one says D-Star. What's D-Star all about? Let's find out. D-Star is digital modulation. And digital modulation means more than just digital voice, but also digital data in D-Star. Now, the digital data in D-Star is at 128 kilobytes. And although in D-Star we call that high-speed data, it's really not very high speed at 128 kilobytes. Now, the digital voice is the important part, and the digital voice is not like the old AX.25 packet radio that's still around today. So you can't really get your TNC out and run D-Star. Whole different thing, completely different approach to data. But there are other data, vocal data or voice data approaches. There's D-Star, as we mentioned, then there's DMR, and DMR is kind of the same thing as Moto Turbo, and in that design there are two slots. In other words, two conversations can go on in slots simultaneously, and that's really the biggest advantage of that. The next type is DPMR. Not a whole lot of use of DPMR these days. It meant digital private mobile radio, and there really isn't much going on with that anymore. P25 is the old APCO 25 that was designed by the Association of Chiefs of Police. P25's had a lot of commercial support. Motorola's done an awful lot of development, but it is an open format, and GE and other people make equipment, Johnson. P25 is in amateur use. There is some out there, but there aren't a whole lot of repeaters. And then we have Yaesu Fusion. Yaesu Fusion is very unclear as to what it actually can accomplish and what it does. There's a large system working in Tokyo. Right now it doesn't appear to be on the internet yet, but slow but sure. The best way to approach Yaesu Fusion is to say we don't really know what it can accomplish, although we've read a lot about it, we haven't really seen it do it yet. So, looking at that, D-Star, DMR, DPMR, P25, and Fusion, if you take all of them minus D-Star and add them up, and then compare that to D-Star, you have the availability of roughly less than a tenth of the D-Star repeaters. So there's very, very few repeaters available to you to pursue any of those others. And very few commercial radios available. By commercial, I mean amateur radio ready commercial uses. Yes, you can buy a Motorola radio for P25, and you can buy the rib box and the cables, and you can get the software, and you can program it for amateur frequencies. But you got to be able to do that. Now, we said there are certain major advantages to D-Star. What are those advantages? The first one, unquestionably, is spectrum utilization. The D-Star signal is far smaller in width than conventional FM. That's a major advantage because it means we can allocate more channels. We can close down the separation between allocations which means more repeaters and more pairs available. On VHF where I live, that would be huge. You really need more pairs. Very hard to get a coordination in Michigan. Next, we ID on every transmission. Every time you kerchunk and press the push to talk, your call sign goes out. So that is automatically ID'd. And in fact, in checking into groups occasionally, they'll say just kerchunk to check in and copy the calls. Next, call sign routing. So a big advantage of D-Star is that the way the network is fabricated, you can tell the network where to take your signal. So you can route to a zone, which means route to a specific repeater, or route to an individual, or route to everybody. It's up to you in terms of how you set up the radio. We also have crossband that's extremely easy. And when we do talk about programming the radio, we'll show you how easy it is to do crossband contacts with D-Star. And there's interleaved text data, and by that I mean there's a 20-character long ASCII area where you can put in whatever you want to put in, and people put in all kinds of things. Some people put in the radio they're using, other people put in where they're from. I put my internet address in there for email because people pick it up and use it and send you emails after contacts very frequently. And if there's one more advantage, and that's there's a Motorola white paper out there right now that shows that digital modulated signals, because they're narrower, actually have greater range. Now, it's up to you. You can read the paper and make your own decision. It's pretty well supported. There's one last really cool advantage, and that's GPS data that's also a part of the transmission. So if you wish to allow it, your GPS location goes out with every click of the push to talk. And that's really cool using a function called DPRS, very similar to APRS, that allows you to go to the Finnish website and track everything you've done, or one of your buddies. And we'll look at that too. So in summary, with every press of the push to talk, we have digital voice data, we have the user data, or the caller ID, we have the routing as control data, and then we have the GPS data. A lot goes on in D-Star on the digital voice side.